All right, boys, so we'll just do a few more examples on this before you have a go at this yourself. So example 2, find the value of a car after 7 years if it is purchased new for $49,990 and it's depreciating at 12% per annum. Okay, don't forget this is per annum, which means per year. So all our times are fine per year and years, so we can just start with the formula. So over here we're starting to do our capital R, put our depreciation rate of 12 in here, and we get our decimal to be R equals 0.88. Then come over here, we're putting in our original value of the car, times by our R value we just found, and to the power of 7 years. When you work all of that out and round to 2 decimal places, it will be $20,429.69. In part B, so in this one they're asking for the value of the car, and in part B they're asking for the depreciation. So the depreciation is going on to that second stage of the formula. So we have a car that was worth $49,990. It's now worth $20,429.69. The depreciation is how much money you lost, right? So we're getting the bigger number minus the smaller number, and that's how much money you've lost in 7 years, $29,560.31. So next time you see a car and you think you want to buy a more expensive car and buy it brand new, just know that in 7 years you'll have lost nearly $30,000. Okay, looking at the next one. Furniture. It also depreciates unless it happens to be an antique that was used by royalty or something. So for furniture with an original value of $27,500 and a depreciation rate of 15.5% per annum, we are calculating its value after 4 years. So that's the first stage of the formula. So we're putting our depreciation rate in over here and getting our decimal worked out. Don't forget that we're just double checking here. We've got per year and 4 years. Per annum is per year and for 4 years. So the units are all fine. You can put this number in over here now. So we've got our original value of the furniture times by 0.845 to the power of however many years it is. And when you go to your calculator and round it off to 2 decimal places, its value after 4 years is $14,020.37. Now in part 2, it's a bit harder. You need to think about it, but we did do percentages back in year 8, and as long as you can read the words and understand how to create a formula from the words, you'll be fine. So what it wants is for you to calculate its value after 4 years as a percentage of its original value. So in other words, we circle the word percentage. We know there's going to be a times 100 in the working. And if you read the rest of the words, it says value after 4 years of, that means out of, original value. So on the top, the value after 4 years. On the bottom, the original value. Okay? Just put the numbers in, put in your calculator, and they want it rounded to 1 decimal place. Be careful with the rounding here. That's 5 or more, so this goes up by 1, which goes to a 0. So we have to actually put this digit up by 1. So it's 51.0%. That's all you've got left after 4 years. So it's pretty much halved its value. All right, now this question's harder again. And I'll explain a little bit on how to do these when you get them in your homework. So a DVD recorder, originally valued at $225, depreciates at 10% per annum per year. So they're asking approximately how long would it take the DVD recorder to halve its original value? Okay, now we're just going to pretend that we're going to start this from scratch and see how far we can get. So we're going to come over here and put our depreciation rate of 10 in here and get the 0.9 worked out. Now we're going to come over to here and start subbing in. So our original value, P, is 225 times by R. Now you get to there and you don't know how many years because that's what they're asking you. How long? That's time. So we don't know that. So you keep it as an N. But this thing's got to be used somehow. Now, you are now halving the original value to get its current value, right? So if it was originally $225, then we are going to halve 225 to get 112.50, right? That's what half its original value is. So we can put that, I left the zero off, but that's okay. I put that number in here because that is what we want the value to be now. We want it to be half its original. So we want it to be 112.5. So I'm going to put that number in here. Now, you are solving an equation. So we want to get rid of this, come to the other side, and do the opposite, which is divide by 225. It's gone from here, it's over here, and we're dividing by it. Now, if you work that out on your calculator, you'll get 0.5 or a half. I'd rather you write it as a decimal at the moment because this is a decimal. So we've now got 0.5 equals 0.9n. So we've got to try and work out this n value, and I haven't taught you how to solve an equation using that. It's actually year 11 work. So I'm going to stick with the way they've worded this question, and they've said approximately how long. So they don't want an exact answer here. Okay, so we are going to use trial and error. So what we have to do is just guess something for n. So I've decided to guess n equals 6. So I'm now going to work out what 0.9 to the power of 6 is. Now if you use your calculator, that's what it works out to be. I need it to be really close to 0.5, and it is pretty close. So I thought, okay, I'll just go one number higher and see what happens. So now I'm using, I'll just write this word use instead of abbreviating it. Okay, so now I'm going to use n equals 7, put that in, 0.9 to the power of 7, and see what the calculator gives me. Now, what you'll notice is that if you look at these two decimals, 0.5, which is what we actually want, is somewhere between there. So our answer is somewhere between these. So it's between 6 and 7. And this is all in years. So we say our answer is between 6 and 7 years. Right, so that's a bit tricky, that question, but with practice you will be able to do them. Okay, so it's your turn now to have a practice at these.